Ravenscraig Steelworks was one of the largest industrial landholdings in Europe, with a long and varied history of coal, iron and steel making that started in the mid-19th century. By the turn of the century, industrial activity had been attracted to the surrounding land, and from the 1950s, a fully integrated iron and steel works was developed on the site. The main works were constructed on 2 artificial terraces, created by extensive earthworks and involving the culverting of the South Calder Water, a tributary of the River Clyde, beneath the site. When the works closed in 1992, British Steel embarked on a comprehensive programme of demolition, site investigation and environmental study to identify the best way of making the site safe and repairing the landscape for the future renewal of the area. The first step was to commission specialist environmental consultants Enviros Aspinwall to carry out a comprehensive review of the whole site and its past activities, and identify the environmental issues that would need to be addressed before any redevelopment could be considered. Enviros Aspinwall's report showed the existing surface and subsurface to be contaminated with metals such as iron, zinc and lead from the steelmaking processes, together with complex cyanides, sulfides and oils from byproducts. This contamination was determined to have been generally confined to specific areas where the various processes were carried out. These included heaps of process residues, sludges in sumps and lagoons, and contaminated soils under stockyards and process areas. The review enabled subsequent efforts to focus on those parts of the site where the main contamination was located, and for a remediation strategy to be planned. Trial pits, boreholes and laboratory testing were carried out to confirm the extent of the contamination and the quantity of materials involved, so that options and costs for their removal and treatment could be prepared. Developing a strategy for remediation required careful assessment of all available options and consultation with the planning and regulatory authorities. All relevant issues had to be fully explored and costs analysed before selecting the best solution for the site. The best practical environmental option was to construct a containment facility on the site, designed to take the range of contaminated materials found at Ravenscraig and engineered and monitored to ensure protection of the environment in the long term. Whilst the chosen solution was straightforward in concept, translation into detailed proposals required much planning before the development could proceed. Formal consents had to be obtained and the process subject to extensive consultation, monitoring and review. Further assessment was needed to choose the most appropriate location for the facility. The area selected was the former slag processing area, which itself needed clearance and reshaping. This area adjoined an existing landfill, and the whole area could be readily transformed into an attractive landscape once the filling was complete. A detailed design of the proposed facility, known as the Secure Containment Facility, or SCF, was prepared. This included a high-specification, multiple-layered liner system and low permeability cap, using a combination of natural clay materials available from the site and artificial membranes. It also incorporated the required degree of environmental protection and monitoring, safety and security elements, and a phased programme of infilling and restoration proposals. Consideration also had to be given to how the remainder of the site would be left after the contaminated materials had been excavated and removed. The SCF area was excavated and graded to form the right shape for the containment facility, the base of which would allow free drainage to a collection point for future monitoring and control. The site was prepared in a series of cells, with each cell designed to take between 1/4 and 1/3 of the total contaminated materials to be excavated. The artificial lining material was laid on a prepared base of graded slag to ensure that no sharp objects would penetrate the plastic. The material was delivered to site in large rolls, which were kept until needed in a secure storage compound adjoining the prepared base. The liner was rolled out carefully over the full area of the cell and the edges checked for gaps. The edges of the membrane were then welded to form a seal. At each stage, the work was inspected carefully to ensure that there were no holes or weaknesses in the materials that could lead to problems in the future. Laboratory tests were also carried out by the contractor and independently checked by the supervising engineer to make sure all materials met the strict standards demanded. This process was repeated for each layer of the lining system and for the associated drainage pipes. Only when the engineer and regulation authorities were fully satisfied with the quality of the system could filling begin. Contaminated materials came from a variety of sources on the site. A large quantity of filter cake residues formed heaps of material above ground, and these were excavated and transferred to the SCF until the level of the surrounding land was reached. The nature of this material made it useful in being able to form a buffer layer between the liner and some of the sludges, pipework and contaminated demolition materials. Other materials, in particular the sludges and contaminated soils below the byproducts plant, had to be excavated below ground. Where soils were excavated below ground, the resulting hole was graded to make it safe, and if necessary, backfilled with clean material and drainage installed so that permanent ponding of surface water would not occur. All materials were delivered to the SCF in dump trucks. Each truck had a unique identification number, so that the source and type of excavation material could be recorded and operations controlled, so that only the correct materials were placed in the facility. Once tipped in the SCF, the materials were spread by dozer and compacted with a following roller to ensure that a stable landform was created. Excavated material was monitored and comprehensive records kept of all materials disposed of. The extent of each excavation area was also monitored, with sampling and testing carried out to make sure all the contaminated material had been removed. When the filling of each cell was complete, the materials were covered with a comprehensive cap, comprising layers of clay and artificial plastic similar to the initial lining. The final restoration and landscape planting were important elements in the overall scheme. The landscape proposals were designed to reflect the site's local setting and future redevelopment opportunities, and included a mix of open grass and woodland. As there were no suitable natural materials available on the site, clean soils were imported and spread to depths for plant growth. Fertilizer was added, grass seeded, and trees planted. A comprehensive programme of aftercare, to include the maintenance of the grass and woodland planting, forms part of the long-term management of the site. Long-term care forms an integral part of the SCF development. This includes a treatment plant for the small amount of liquid which forms within the containment site and is drained through a series of pipes in the base of each cell. Monitoring boreholes have been placed within and around the edge of the SCF, and regular checks are made of the water and air quality. Surface water is also sampled regularly to make sure the river quality is maintained for fish, wildlife and plant life. A master plan has been prepared for the whole site, which provides a vision of renewal and regeneration for the town of Motherwell. The site clearance and decontamination works carried out by British Steel will contribute to the realisation of this vision by preparing an attractive and safe landscape to build on for the future.